Okay, so now we're going to solve logarithmic equations. So Wednesday and Thursday, you should have tried, some of you Wednesday, some of you Thursday, should have tried solving exponentials using logarithmic properties. Now we're going to use logarithmic properties and things we know about their inverse, which is bases, to solve logarithmic equations. So the first thing you always do is you look at it and you go, okay, I need to really get the logs on one side. I want to get them all the same side. So the first thing we're going to do is we're going to add the log base 2 of 2x to both sides. Now you can't add the two things together, but we can use log properties. So that cancels out. And we end up with log base 2 of x minus 6 minus log base 2 of 2x equal to 5. From log properties, we know that if we're subtracting two logs, then we can combine the arguments with division. So this is going to become log base 2 of x minus 6 divided by 2x. And that equals 5. Oh wait, I added. That's a plus. Sorry. I did pay attention to what I was doing. So that's a plus. There we go. And this becomes log of x minus 6 times 2x equals 5. Now, here's our problem. We got a log on one side. We got something that's not a log on the other side. Now, you can do that whole switcheroo, and that's the way a lot of people teach it, but I want to teach you what you need to do for calculus and for harder problems. We can do this on easy ones. You can do the switcheroo, but on harder problems, you need to know that you can undo this with the inverse. Just like we undo a square with a square root, and we undo a square root with a square, we're going to undo the log with base 2. So on the left-hand side, I'm going to raise that all to base 2 so I can undo the log. And if I do it to one side, I have to do it to the other. So the inverse of log base 2 is base 2. If I take all of that and make that the exponent of base 2, both sides of the equation, I can undo this. These are inverses. They undo each other. And you are left with, and I'm going to go ahead and multiply these out. Oops, I didn't want blue, I want red. I want to multiply. It's still not. There we go. I think I got it that time. Yeah. We're going to multiply this out. So that undoes it, and we end up with 2x squared minus 12x is equal to 2 to the 5th power. And 2 to the 5th power, if you played 2048, is 32. It's 2 times 16. All right, if we move that to the other side, then we get 2x squared minus 12x minus 32 equals 0, and we can factor it, but the first thing we're going to do is we're going to get the greatest common factor out. That's a 2. We end up with x squared minus 6x minus 16 equals 0. And now we're going to factor it. This becomes 2 times x. The only way to get x squared is x squared. We have 16. We need two factors for 16 that sum. Okay, it's negative. Since it's minus 16, I know that the two factors, when we factor, are opposite in sign. So one's plus and one's minus. I'm just going to write them both minus for now. We'll figure out which one's plus. So I need something that multiplies to give me 16, but the difference is 6. Well, that's 8 and 2. In order for the negative to be a negative 6, we have to have plus 2 equals 0. And from that, we know that x is equal to negative 2 or x is equal to 8. Now, the problem is they don't both work. Right? One works, one doesn't. So once you get your factors, like when it's a quadratic like that, now you have to check. Hang on. Oh, wait. There we go. You need to check for, they're called extraneous. solutions. So basically, you're checking for solutions that don't work. We go back up here, and the whole point is if we plug in these two numbers, remember, logs have to have a positive argument. If you put in x equals to -2 on x minus 6, that's -8. So what we have to check is, because the logs have to be positive, we have log base 2 of x minus 6, where x minus 6 has to be greater than 0, and we have log base 2x, where 2x has to be greater than 0. Well, for both of them, if you plug in the 8, it's fine, but if you plug in -2, -2 would give you -8 or -4. So for those two to be positive, because of this condition right here, x cannot equal -2. So the only solution is the x equal to 8. So after you go get your solutions, you should always just go quickly check and make sure you didn't make a mistake, or that one of the solutions is not extraneous, meaning that this works for the 8 but not the 2, and it's because it's a quadratic. Okay, for our next one, remember, we want to get the log by itself. So that means we're going to add 1 to both sides. And that gives us 2 log base 5 of 4x equals 4. Now, what we can do now is we have this, that's the product. See the product in here? That, we can make that 2 log base 5 of 4 plus 2 log base 5 of x equals 4. And I actually, hang on, I'm using knowledge you don't know. Let's do something first. Let me not lose you. First, we're going to move this up and we're square it. Remember from exponentials that if you square something, you square both things. So it's 4 squared x squared equals 4. Now don't change that just yet. Hang on just a second. And then now we know that's a product. So now we have log base 5 of 16, or 4 squared. Let's leave it as 4 squared for now. 4 squared. 4 squared plus log base 5 of x squared, right? Actually, that's not the easy way to do this. I was about to do it hard. Let's not do it hard way. There's a much easier way. We have 2 log base 5 of 4x equals 4. Before I even do any of that, because remember, I want the log by itself, I can easily just divide by 2. Much straightforward. That means I get log base 5 of 4x equals 2. And now I want to undo something that's log base 5. And the way we undo it, we find the inverse, which is base 5. And what we do to one side of the equation, we do the other. And that makes it, then we undo this. Remember, these are inverses and they undo each other. I'm left with 4x equals 25. And then x equals 25 divided by 4. There's only one solution and it works. You just put it up here. You put 25 over 4 in here, that you would get a 25 for the argument, and 25 is a positive number, so it works. All right, for our last trick, once again, we're going to do the same thing. We are going to subtract 3 from both sides. We get 4 natural log of 2x minus 1 equals, well, 11 minus 3 is 8. So we're going to divide both sides by 4. That leaves us natural log. Remember, do all the simple algebra. That was what I forgot to do. Do all the simple algebra first so that your equation doesn't become too complicated. And then now we know that the base, that is the inverse of natural log is the exponential function. So it's exponential base. Sorry about that. It just jumped on me. So, oops. We take the exponential from both sides, which is the inverses. Those inverses undo each other. So we end up with 2x minus 1, oops, equals e squared, which is perfectly acceptable. That's just a number. It's the number. It's about 2.718. Goes on to, keeps going. The decimals go on to infinity and beyond. Never repeating. Well, you're just squaring that number. E is a number. So I'm solving for x. So it's just like algebra 1. We're going to add 1 to both sides. We get 2x equals e squared plus 1. We're going to divide both sides by 2. And our final answer is x equals 2e squared plus 1 over 2. Easy peasy lemon squeezy. All right, so now you're going to try these and practice them.